All right, hello Remington and Olivia. This is the second half of Chapter 7 review. We're going to try to get through this today. We're starting with number 12. Okay, number 12. All right. Adding. We're adding these two together because there's a plus sign, correct? That's for you, Araceli. Plus sign. What do we have to do?
You have to get a common denominator.
Find a common denominator. All right, are these trapped or not trapped?
Trapped.
Toby. Trapped. Okay. All right, first things first. Before we find a common denominator, what do you got to do?
Greatest common factor.
Greatest common factor. 3 times x plus 2 if I pull a 3 out, right? So, looking through my denominators, common denominator, I know I need an x plus 2 in it, right? And I know I need a 3. And I know I need an x plus 2, but do I need a second one? No. So, 3 and x plus 2 and 3 and x plus 2. There we go. All right, and I've got 3 on the top and 4x plus 5 on the top. And I'm going to multiply by what he needs. Okay? All right, so looking at the left side. Comparing x plus 2 to 3x plus 2, what does he need?
3.
He needs a 3. Comparing the right side, what does he need? Nothing. So I'm going to put him away. Now, do I get to cross the bottoms off?
No.
How's come?
Because it's not equal.
There's no equal sign. Okay, I guarantee you somebody's going to do it on the test. Don't let it be you. Somebody will do it, though, every year. I always say that, and somebody always does it. Somebody always crosses the bottom off when they're not supposed to. Okay, so this guy up top here, if I put it all under one roof, 3 times 3 is 9 plus 4x plus 5. Okay, all over 3 times x plus 2. But we're not done yet. Some of you guys can add that together in one step, and that's fine. I don't care. Final answer? 14 plus 4x, or 4x plus 14. I don't care how you read it. I usually put the x first. Okay, and like that. And can I cancel this 2 with this 4?
No.
Absolutely not.
Absolutely not. Absolutely not. We're going to leave them like that. Okay, if you want to distribute the bottom through and make that 3x plus 6 on the bottom, go for it. You don't have to. Okay, happy with that? All right, shall we do this one off to the side over here? Okay, all right. Don't get ahead of me on this problem because they were really mean to you. They were really mean to you. I won't be this mean to you. Actually, it comes out really nice, but they were really mean to you. So let's break stuff down, all right? This bottom, there's a trapped, right? We're adding, we have to find a common denominator, but these are trapped. This guy is a simple trinomial, right? Okay, what can you multiply to get 1 but add to get 2? Positive 1, positive 1. X plus 1 and x plus 1. Got it? What about this one right here? Difference of squares. X plus 1 and x minus 1. Okay? Now, normally we don't have to worry about factoring the tops, but I'm gonna. Look at this 3x plus 3. You can take out a 3, right? Greatest common factor. Pull out a 3, right? And then you have x plus 1. All right, now here's the deal. Oh, and this x minus 1, you can't do anything with that, right? So he just stays x minus 1. Okay, now, normally, we don't worry about canceling, but if I look at this, is this term right here reduced?
Yeah.
Like the way that he is now? Is he reduced, or can I reduce him more? Can I get rid of the x plus 1s?
Yeah.
Like that's one term right there. Like I can reduce that, right? So this is 3 over x plus 1. I haven't even found a common denominator yet. Okay, I'm just reducing that one side, which normally we don't have to do because it's already reduced, but this one's not reduced to begin with. Plus, what about this guy over here? This term.
X minus 1.
You can cancel the x minus 1. So what does he look like?
X plus 1.
1 over x plus 1, right? You have to have a 1 on the top because everything's gone. Okay, now take a look at what's left over. 3 over x plus 1 plus 1 over x plus 1. He already has a common denominator, right? Look at that. 4 over x plus 1. You see that?
That's pretty simple.
That was weird. Okay?
No,
That's not the way that we normally do it, but what they were doing is they were giving you the 2 pieces that they were giving to you were not reduced to start with. Does that make sense? And we had to reduce them to begin with. Make sense? Okay? So, 4 over x plus 1. Done. Got it? Happy with that? Okay, that was 13. All right, number 14. Now let's do, number 14. These are graphing these 1 over x functions which look like boomerangy things, right? Okay, they're the boomerangs. And they want us to find where the va is. They want us to find where the ha is. They want us to find where the domain and where the range is. So va, ha, domain, and range, right? Okay. All right, where's that vertical dotted line at? Up and down. Where is the dotted line at? 0, right? You see him? Put him in there if you need to. Where's the horizontal one at? Also at 0, right? 1 over x is just the basic main function. He's 0 and 0, right? So for a ha,
X equals 0.
ha is x equals 0.
Y equals 0.
Va, or excuse me, va is x equals 0. Ha is y equals 0. Okay?
And then Y not X not equals 0.
Domain goes with the va, so that's x can't be 0, right? If there's a
There's
va
no
there, then x doesn't touch 0.
And Y
For
not
the ha,
equals 0.
Y doesn't touch 0. Is that too fast? Do you remember doing that?
Easy.
Toby's like, I'm on top
Only
of it.
thing I know
We are
from
good
the
to
whole
go. We are good to go.
Uh-huh.
All right, good? Happy with that? 15, we gotta do the same thing. Va, ha, domain, and range. Va, ha, domain, range. Just keep in mind that the va and the domain go together, ha and the range go together. Okay? All right, where's the vertical one at?
No.
Where's the vertical straight up and down one? This is kind of hard to see maybe.
One.
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 Or no, one.
At 1, okay? Now, I can look at the equation and tell you that it's at 1, right? Look at this, x minus 1. That means right one, right? Minus 1 means to the right one. So he's up and down at the right one, right? Where is the horizontal one at?
3. Oh no.
0. He stays at 0, right? Okay, I don't see him moving at all. So there he is, right? So the horizontal or the vertical one, x equals
1.
1. The horizontal one, y equals
0.
0. Domain, x is
No 0.
not equal to 1.
You are different.
Range,
No,
y is
no 0.
not equal to 0. Yeah, there we go. Okay. All right, 16, same thing. Va, ha, domain, and range. This one's harder yet, I think, even, because it's like, where is everything located? I don't know where your vertical one is. Do you see where your vertical one is?
Is it negative 1?
How do you know it's negative 1?
Just look at it and then flip it.
Look at the equation. X plus 1 means left 1, right? So I know that my vertical one is at negative 1, right?
No, it's
Okay, that's my my va. X equals negative 1, okay?
And up 2.
And he's up 2, so this guy tells me that my horizontal one is at 2. Do you see how that works? So from the equation, use that to your advantage. Y equals 2. That means for domain, X is not equal to negative 1. Y is not equal to 2. Got it?
We're done.
Yeah, there we go.
We're done for today.
What?
We're done for today.
We did the whole side.
How did we get?
How did we get what?
Never mind.
Now summarize.
That's fine. Ask. Ask. Last period, we were going through stuff, and Matthew was trying to work ahead of us, and we get to the end of the problem, and I'm like, this is what I got for an answer, and he goes, oh. And he was like defeated. He's like, I did it wrong. I did it all wrong. I screwed up in the beginning. I said, better now than when you take the test, right? That's why we do the review. Make your mistakes now. Get your all your kinks worked out now, okay? All right, backside. These ones, they don't have them graphed, 17, 18, 19. Let's start with 19 and work backwards, okay? Because this one has all of the things in it, okay? So let's start with 19 first. I'm working on 19 first, the top right corner first, okay? Let's talk about the 5 and the 3. How does the 3 move it?
Up.
Up 3, okay? So
And-
up 3.
and left 5.
And this is left 5, right? Because plus means minus, right? So up 3, left 5. All right, so normally we start at 0, 0, but we're going to go left 5, up 3, and I put my dot there. Now, what does that dot do?
This is the middle.
That's the hum.
That's where your ha and va cross, right? So I just put my va and my ha right there.
Uh-huh.
And I just make these little guys. That's what he looks like, okay? All right, and they want domain and range. I'm going to do the va and the ha at the same time because, like, that makes it easier for me. So they're not asking for the va and the ha, but I'm gonna list them just because it makes it easier. The vertical one
X not equal.
is x equals
Y.
negative 5. The ha, y equals 3. Okay, that means domain, x is not going to touch negative 5 because that va is there, right? And the range, the y values are not going to touch 3 because the ha is there, right? Like those are the dotted lines and they're not going to touch, right? Yeah, that's not too bad. Good?
Not yet.
Okay,
Still right.
all right. I graphed that kind of fast, so. And I'm not going to judge your little loop-de-doos. Mine obviously look terrible, so whatever. It's
I
fine.
just need to get them.
Okay? The main thing is you want to make sure your va and your ha are in the right spot. because that tells you your domain and range, right? Okay. All right. Middle one. Let's work 18 now. So let's talk about, what does this minus 2 do? He doesn't have a number off to the side over here that we're adding and subtracting, which
Right
means we're
2.
not moving him up and down at all, right?
Right 2.
So we're going to the right 2. Okay.
Which one?
Right 2. To the right 2. Now, let's talk about
0.
the negative and the 2 are doing 2 separate things, right?
Vertical stretch. Over the
The 2 is a vertical stretch. What does a vertical stretch do?
Makes it
bigger.
C shape.
It's more of a C shape. More C shape, okay? And I'm not going to judge your C shape because your C shape doesn't change the domain and range, right? Okay? So, whatever. More C shape. What's a minus do?
It flips it.
It's a flip, right? So instead of him being here and here, he's going to go in the other corners, right? In like the second quadrant and the fourth quadrant, right? That's what the minus does, okay? All right, so really the only number that's going to change my va and ha, though, is this bottom part, is the part in pink, right? So normally he starts at 0, 0, right? But I'm going to go to the right 2. Not up and down any, I'm going to go to the right 2. And that's where my va and ha are going to cross. Does that make sense? That's my dotted line, okay? Use to the right 2. Right 2.
yeah.
What? You're all looking at me like, what are you doing? To the right 2. I was just seeing if you're paying attention. That's what I was doing. Bull crap. Okay. Second and fourth quadrant is where we're gonna put him, and more of a C shape. So like more of a C and less of an L. Okay, more of a C and less of an L. Okay. All right. Va and ha and domain and range. Okay. All right. What's the vertical asymptote look like?
X not equal to and yoi.
This one's x equals 2, which means your domain is x is
And
not
y,
equal to 2, right?
Y not equal 0.
Y equals 0, and y is not equal to 0 for the range. Make sense? Are we doing okay?
Have to.
All right. All right. Last one, 17, that we have to graph. We hate these graphs, right? Plus 1 is the only thing that's changing. 1 over x is what we start with to begin with, right? What's the 1 doing? Up 1, that's it, right? This is the easiest one. So we're going from 0, 0, up 1, so that's where my dot is. And that's where they cross, right? Vertical, horizontal, and this guy is here, and this guy is here, okay? Va and ha and domain and range. Okay? All right, what's your va look like? X equals vertical 1.
0.
X equals 0. Okay, the ha, the y, it's cutting through the y-axis here at 1. Right? Y equals 1. That's the deal. Okay? Domain, x is not equal to 0. Y is not equal to 1. Got it? Good, good? All right. Good, good, good. Okay? Now we have variation functions. 7, 4, you can cross off 7, 4. So there's a big old fat chunk of graphs that we can just like get rid of. Very nice. Okay? All right, 7, 5. To do this section, 23 through 26, we need our equations. We have direct variation. We have indirect variation. They also call that inverse. Write this down out to the side. Direct, indirect, or inverse. Then we have joint variation. Do you remember what the last one was? Do you remember what the last type of variation was?
No.
Simple trinomial.
Combined variation. We have a combined variation. All right, we're going to write these equations off to the side. Okay? All right. For a direct variation, do you remember what your equation looks like? Y equals
K.
kx. That's like a linear function, right? Kx. So like y equals 2x or y equals 1/3 x. That's just a linear function. Indirect or inverse. What does he look like? Y equals k over x. The x is in the bottom. You betcha. Okay? All right, joint variation. This is where two variables are joining together to make a third one.
Y equals KXZ.
KXZ, perfect. That's my joint variation. And then we have combined, and the combined variation is like a combination of direct and indirect at the same time. Okay, so we have three variables. Y equals,
K over XZ.
you're close,
K.
KX over Z. One is in the top and one is in the bottom. So the X part is the direct part, and the z part is the indirect part. Okay. Now, which one of those four is what we graphed up here? What were each one of those?
Indirect.
Those are indirect or inverse, right? So that's why we're talking about like the types of variation is because these are all inverse variation, right? Because the x is in the bottom. All right, so let's go to these. 23. Okay, I don't know if you remember us doing this section, but we kind of separated into 3 chunks, right? Okay, so first we're going to write out what equation we're going to use.
Exponential number.
What are you talking about?
What?
The first one?
The first square.
The first square is your equation.
Oh, I thought it's exponent.
Okay.
Never mind.
Okay. Number 23, if y varies directly as x, what's your equation going to look like? Y varies directly as x. Y equals kx. That's what I usually put in the first spot. Okay? And that'll help me to figure out what to do next. It says y equals 9 when x equals 6. So if y is 9 when x is 6, what do I do in the middle box? You solve for k, right? We're trying to get k by itself. So if I divide by 6, 9 divided by 6 is 1.5. 1.5. Okay? So now, using that information over here, I have y equals 1.5x. And I use the rest of my information. So find y when x is 8. Okay? Do you know what 1.5 times 8 is? Can you do that in your head?
11.
1 times 8 is 8. What's half of 8? 4. 8 and 4 makes 12. Okay? Got it? That's how you do any halves. Especially of even numbers. It makes it really nice. So 12 should be the answer to that one. Got it? Do you want to try to do some of these on your own? Or no?
Are we doing 20
What?
Are we not doing 20 through 20?
No. Nope. We're crossing it off. Because we didn't do 7, 4. Okay? Do you want to try to do some of these on your own and I'll do them quietly?
Yes.
Okay? So you work. I'll give you like a 30-second head start and I will go and then you can check your answer with me, okay? All right? So do 24, 25, 26 using those equations. All right? I will tell you that there's a couple tricky things that happens in there. Sometimes they give you information backwards. And sometimes they give you variables that go in the wrong spot. Wrong spot in different spot. Okay? Okay, so you do it and then check your answer with me. Oh, 24, that's where they give it to you backwards. They give it to you backwards? Ah. Find y when x is 5 and z is 3. That's what goes over here on the right side. That's what we're wanting to find. So you save that information for last. Okay, there's your head start. Keep it going. All right. I think you get to some bigger numbers down at the bottom. Like really big number, like in the hundreds. Yes. I don't know who just asked that, but yes, you're right. Was that Brian? Okay. I don't know if that answer's right. That's not right. 476.
Oh, combined. Okay.
Is that right? 476? No, 470. What is
Wait,
it?
why does the 2 go?
672.
Ah, why does the 2 go on the top? It says it varies directly with Z. This is another tricky one. So directly with Z means Z goes on the top and X goes on the bottom.
That's not very nice of
I know, that wasn't very nice of them, was it? What is it? What is it?
672.
672, that's what it was. And then K is 336. Is that true? Oh no. Then bring in more paper.
Yep.
I didn't get rid of the last one. Okay. Whatever.
Just make someone else do it.
I usually make my husband do it. But I have to get it to my car first. I don't have very much room in my car.
We can do it tomorrow during this period.
Think so? 192. I don't know if that's right. Is that what it is?
Yep.
Haha. I'm just trying to remember from last period.
And how the 26 is direct because it's,
How is what?
how it can be
Good enough.
direct, it's direct.
I just
But we
finished
use the
right now. I
combination.
have to sit through all
What?
this.
Which one?
The combination.
Yeah, this is a combination, but it says directly with
Yeah.
Z. So Z goes on the top and X goes on the bottom.
Oh, this is why.
Ah, that's tricky.
Did you?
So, a couple tricky things. There it is. Okay?
But he's admitting.
26. The Z goes on the top and the X goes on the bottom. Good, good?
I don't like it when you do that.
Wait.
You don't know which one to go on top.
What?
Because I don't like it when they do that.
I know. The direct always goes on top. The inverse always goes on bottom.
I never know which one.
Yep. Direct always goes on top. Inverse always goes on bottom. Okay? All right. Did you get through all those? Did you get the same thing I got?
Yep.
Yeah? Are we ready for the last 4?
1 second.
1 second. Okay. You just tell me.
So on the test, will the equation be on there?
No.
So we have to remember them?
No.
We'll get a note card? What?
I'm gonna let you use your review on the test.
Yes. Yes. I don't know.
What?
You use the review on the test.
I'll let you use your review on the test. I was gonna wait to tell you until we were done, but whatever.
Oh, thank goodness.
I'll let you use your review on the test. So make sure that you at least have these equations written down on your review. So make sure you have all that ready to go. Araceli, I recorded the front half of this, what we did yesterday, and I sent it to you in an email. So you'll be able to write that down from the front side. What? Sure, I can. Yep.
Are you gonna have any questions like 26 on the test?
26.
Directly and inversely?
There might be a combined one, but I'll try not to make it so tricky where your variables are wrong or whatever in the wrong spot. So there's that. Okay. All right, 27, 28, 29, 30. These are like all in one section. Let's talk strategy. Like number 27. What are we doing here? Like, what do you do first? What do we got to do? Common denominator, right? Least common multiple. We have to find a common denominator. Do you get to cross the bottoms off when you get a common denominator?
Yes.
Why, yes.
But there's an equal sign.
There's an equal sign. So, just so that we're clear, the ones that we started with today, like these guys, number 12, we did not get to cross the bottoms off because there's no equal sign. We're just combining, right? So we had to have the denominator still. On the bottom ones, there is an equal sign. We got to cross the bottoms off, right? All right, so here's the deal. 27, we've got this guy minus this guy equals this guy. There's my fractions, all right? Let's find a common denominator. 3, 4, and 2. 12. I'm going to make them all 12. Now, here's another thing that I'm going to do. We are subtracting. I don't like to have the minus sign there because I forget to distribute the minus through. So I'm going to make him plus. But if I make that guy plus, what happens to the x minus 5?
X plus 5.
Negative x plus 5 is what he will do, right? I have to distribute the negative through. So I do that so I don't forget to do it later. Does that make sense? Okay?
Yeah.
Then I've got 2x plus 1 and 1 here, and I've got to multiply by what they need, right? Multiplying them by what they need. So do you see what I did to distribute the negative? Okay, there he is. All right. Are we good to go? Am I going too fast?
No.
Okay. From 3 to 12, what does he
4.
need? He needs multiplied by 4. From 4 to
3.
12, he needs 3.
No, I said it.
6.
Did you say 8 or
No, I
3?
said 3.
Oh, I thought you said 8. Okay. We're not adding, we're multiplying.
What, 8? No, I know it's
Well,
3.
8 would add, right?
Oh, I didn't even think about it.
Hey, yeah. Okay, 2 to 12. He needs 6. Cross the bottoms off. That's my favorite.
What are we on?
All right, so now we multiply stuff. So this guy right here, yep, 8x plus 4. All right, what about the second piece?
Minus 3x plus
Plus.
15.
Minus 3x plus 15 equals
6.
6. Perfect. Beautiful. Beautiful, beautiful. Got it? All right, now what would you like to do? Here's my equal sign.
Minus 3x.
No.
What?
Or plus 3x.
No.
Same
What?
thing.
You just
combine them.
You combine
It's
it.
Well, I wanted
5.
plus
It's
3.
5.
So
X.
plus 3, yeah.
Just combine them.
I would combine this 8x
This
and 3x because they're on the same side,
Yes.
right? What's 8x minus 3x?
Same thing.
5x.
5x. Okay, now here.
This is
Somebody was
equal.
doing this last period. Ready? Okay, watch this. Somebody was doing this last period. So explain to me why this doesn't work. Plus 3x plus 3x. So they get 11x.
They're on the same side.
They're on the same side. Do you see that? Okay, but that's a common mistake people make, right? If they're on the same side, you don't like use the opposite sign. You literally just combine those together. So what's 8x minus 3x? 5x. Okay, now can we put the 4 and the 15 together?
Well, you're gonna move them on the other
Yeah.
side, so what?
19.
Well, I'm gonna put them together first before I move it. You can move them individually to the other side, but I'm gonna put them together before I move it,
You
right?
can move it straight, like.
Sure. You do that.
You
do that. Minus the 19 over. Ugh. 5x equals negative 13. That doesn't divide by 5. X equals
No.
Negative 13 fifths.
negative 2.6 or negative 13 over 5. You can leave it. I don't care how you leave your answer. If it doesn't come out nicely, you can leave it as a fraction. Whichever one you like better. Okay? All right, good. That was 27. All right, 28. What's the denominator on 4?
1.
1, right? Okay. So now I'm looking for a common denominator. 10m, right? 10 and m and 10 and m and 10 and m. Are we getting better about like identifying those and stuff? Okay. All right. We've got 3m plus 2. We've got 2m minus 1. And we got 4. We got to multiply by what he needs. Needs. All right. 5m to 10m, what does he need? 2. 2m to 10m, what does he need? 5. 1 to 10m, he needs the whole thing, right? 10m. All right, then what do? Cross the bottoms off. That's my favorite part. So satisfying because it makes it so much easier. All right, so I just heard Toby say 6m plus 4. True? Plus 10m minus 5 equals 40m. This answer comes out really disgusting, by the way. Yuck. Okay, what would you like to do? 6m and 10m. That makes 16m because they're on the same side, so you're going to add them together. What about 4 minus 5?
I already did it.
You already did it. You're just ahead of us. Minus 1. Okay, we got that. All right.
4 minus 16.
Then subtract 16m minus 16m. All right, negative 1 equals, that's like something like 24m. Ugh, then what? Divide by 24. Ew. So negative 1 over 24 is your answer, or you can convert it to a decimal. I don't care. I'm going to leave it as negative 1 over 24 because I'm going to be lazy. Yuck. Gross. Bad answer. Okay? All right. Ready for the next one? 29. This guy minus this guy equals this guy. We have a minus sign again, so be careful with that. We've got 2x, we've got x, and we've got 4. What's your common denominator going to be? 4x? Right? Because 4 has to go into it, right? So it'd have to be 4x. 4x, 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 right? Okay, that's my common denominator. I've got 3. I'm going to take that minus sign. Anytime you have a minus sign, change him to a plus, but this has to become minus 2 on the top. That way you don't forget that he's minus, okay? And then we have 1, and we got to multiply by what he needs. Okay, switch my color here. All right, we doing okay so far? You can stop me. Better we work out the kinks today than Monday, right? All right, from 2x to 4x is 2, right? From x to 4x,
4
we need 4. From 4 to 4x, we need
x.
x, right? Are we doing okay with that? All right, 4x is gone on the bottom. Hey, this one's really nice. All right, 3 times 2. This is 6. Negative 2 and 4 makes negative 8 equals x. So, we don't even have to move anything really. Negative 2.
-4, yeah.
That was so nice. Yes, x equals negative 2. But you like to, Megan says you have to switch it around, right? Because the x has to be on the left. Megan is like a type A personality or whatever it is. Okay, I'm going to tell you 30 is not going to be very nice. I don't think I will give you one like this on the test on number 30. We're going to do it. We're going to go through it, but I'm going to show you why it's ugly at the end, okay? He does have some ugly stuff, okay? First and foremost, what's the denominator on the 1? 1 over 1, right? Okay, but Ethan just said x squared minus 1 is a difference of squares, right? He said x plus 1, x minus 1. Do you see that? The square root of 1 is 1. That one's hard to remember. Like, because 1, you think it's completely broken down, but that's x plus 1, x minus 1. All right, so I've got this guy plus this guy equals this guy. What's your common denominator going to be?
Plus 1 minus x minus 1.
Yeah, x plus 1 and x minus 1. He has to have each one of those pieces, right? X plus 1, x minus 1, x plus 1, x minus 1. There we go. Okay, I've got a 3, and I've got a 1, and I've got a 2. And what they need, and what they need, and what they need.
3 doesn't need anything.
The 3. Ethan says he doesn't need anything. Is that true? Okay, all right, the 1, what does he need? Everything. All right, now, rather than writing up here at the top x plus 1 times x minus 1.
Square minus 1.
What is x plus 1 times x minus 1? I'm going to put x squared minus 1 so I don't have to FOIL back out again. It's already done for me, right? Does that make sense to put that in that spot, right? Work smarter, not harder. What's the 2 need?
Just x plus 1.
X plus 1. Okay. All right. This is going to be kind of ugly. Cross the bottoms off. All right. 3 doesn't need anything, so he's just that. 1 times each one of those is just x squared minus 1 equals, what's it equal to?
2x plus 2.
2x plus 2. All right. Now let's figure out the rest. What would you like to do now?
The number, so it's 2, so it's 2x.
Can you combine
4x.
3 and minus 1?
Yes.
Yeah, what's 3 minus 1? They're on the same
0.
side.
2.
What is
3
good?
minus 1 is 2,
Why did you
right?
put it on the other side?
If I can put those there, you
Yeah.
just wait a second. You're ahead of us. 3 minus 1 is 2, right? Okay, so if I combine those, that'll look like that, right? Okay, then Toby says, now let's move this 2 over here. And what happens? It's gone, right? Do you see that? It cancels with the other side. So I've got x squared equals 2x. Now what do you do? You can't do the square root because there's a x there. Move the 2x over to this side. So if I move the 2x over, it's like subtracting 2x. Can you subtract 2x from x squared?
No.
What will it look like?
X squared minus 2x.
X squared minus 2x equals
0.
0. Okay.
And you can take out an x.
Now you can take out an x like its greatest common factor, right? X times x minus 2 equals 0. Right? Agreed? Maybe? Like, does that work? Okay, we're so close to being done. Now what do we do? We got them broken down.
Set them equal to 0, right?
Set them equal to 0. So x equals 0, that's this guy. And x minus 2 equals 0. Right? So x equals 0, that's just one answer. But what about x minus 2 equals 0?
X equals
I add the 2 over and x equals
2.
2. So I have 2 answers. 0 and 2. Do you see how that works? That was ugly. That last little bit was kind of ugly. It's been a hot minute since we've done that, right? Okay, good. Tomorrow is like Friday, right? It's a Thursday, Friday. You know our Friday schedule, okay? So we'll have shortened class periods. We'll do some whiteboards tomorrow, and then we'll test on Monday.
No.
Make sure that you have this review ready to go for Monday because you get to use it, right?
Can we
You
have
get
test
to use
it
your
Tuesday?
review. What?
Can we test it Tuesday?
There's gonna be people gone like Tuesday,
Monday is like birthday.
starting Tuesday and Wednesday. As soon as like Actions Day hits on Wednesday, everybody's gone for everything, like track and then golf and then Actions Day and then state FFA and state FBLA and like TVC band is one day and whatever else. Everybody's gone. So we gotta use all the days that we can where everybody's here.
Please.
All right, goodbye, people watching this video.
God.